Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized pieces.
Today we're looking at a question that's on the mind of every software developer, and frankly, anyone who uses technology. We know AI can write code, but is it any good?
Right, and not just does it work right now, but is it good in the long run? Can you build on it? Can you fix it when it breaks? This is a concept in software called maintainability.
Think of it like building a house. Two different builders could both build you a house that stands up and passes inspection, but one builder might have used standard parts and clear, logical plumbing. The other might have used weird custom parts and routed the pipes in a bizarre way.
And you only find that out 6 months later when you try to add a new bathroom and the plumber just stares at the wall in confusion.
Exactly. That's maintainability. And this is the central question in a new paper from researchers at New York University and Carnegie Mellon University titled, "Is Agent Code Less Maintainable Than Human Code?"
So how do you even test this? You can't just look at a piece of code and give it a maintainability score. The researchers had to get creative. They built a framework they call CodeThread.
CodeThread is a really clever way to create a controlled experiment. First, they take a real-world coding task from a software project, like fixing a bug, but they split it into two steps, an initial task and then a dependent follow-on task.
Like, step 1 is build the engine, and step 2 is tune the engine for more power. You can't do the second step without the first.
Precisely. Now here's the twist. For that first step, build the engine, they get it done in two different ways. Once by a human programmer using the actual solution from the software project, and once by a state-of-the-art AI coding agent.
And both of these initial solutions work, right? They both pass all the tests for that first task.
Correct. To an outsider, both pieces of code seem to do their job perfectly. But then comes the crucial step. The researchers take the second task, tune the engine, and hand it over to another AI agent.
So they see how the AI does when it has to build on the human's code versus how it does when it has to build on the other AI's code.
Exactly. It's a coding relay race. They call these two scenarios HA for human then agent and AA for agent then agent. This setup lets them isolate one single variable. Who wrote that first piece of code? And does it make a difference to the next agent down the line?
Okay, so the experiment is set. What were the results? Was the AI-written code harder to work with?
It was. The results were quite consistent across different AI models and different types of coding tasks. When an AI agent had to build on code written by another AI, its success rate dropped.
So the agent-then-agent scenario performed worse than the human-then-agent one.
Yes, and not by a small amount. The paper reports that the task success rate dropped by up to 13.1% in some cases. That's a huge difference. It suggests that the first AI, even while successfully completing its task, was leaving behind a messier, more confusing foundation for the next agent down the line.
So the code was more brittle. It worked, but you couldn't touch it or extend it without it falling apart. So the big question is, why? What was the AI doing wrong?
This is the most interesting part of the paper. The researchers first checked the usual suspects, the traditional ways software engineers measure code quality. Things like cognitive complexity, which is a fancy term for how hard the code is for a human to understand.
Like how many twists and turns the logic takes, a tangled mess versus a straight line.
Exactly. But surprisingly, those metrics didn't explain the difference. The AI-written code wasn't necessarily more complex or tangled by those standard measures. The problem was much more subtle.
So if it wasn't the structure of the code, what was it?
The biggest signal they found was in what they call behavioral differences, especially in how the code handled errors and bad inputs.
Can you break that down for us?
Sure, let's talk about error handling. When a human programmer writes a function, they often write it to fail loudly. If you give it bad data, it will immediately stop and raise an error. This is a good thing because it tells you right away that something is wrong.
It doesn't just try to guess and keep going.
Right, but the AI agents tended to do the opposite. They would often write code that would fail silently. If they got bad data, they might just ignore it, or substitute a default value and just carry on as if nothing happened.
That sounds helpful, but I have a feeling it's not.
It's really not, because it hides the original problem. The program keeps running, but it's now running with incorrect data, which can lead to a much bigger, much stranger, and much harder to diagnose bug later.
It's like a bouncer at a club who, instead of turning someone away with a fake ID, just shrugs and lets them in. The problem isn't solved, it's just been moved inside where it can cause more trouble.
That's a perfect analogy. These subtle differences in behavior, these little quirks in the AI's code, created downstream problems that the traditional quality metrics just couldn't see.
So what's the big takeaway from all of this? Is the message that AI code is bad and we shouldn't use it?
The authors are careful to say that's not the point. The point is that we need to be much smarter about how we evaluate these AI coding agents.
A simple pass-fail test on a single isolated task isn't enough.
Because it doesn't capture these long-term costs, the hidden technical debt that gets created.
Exactly. This study shows that maintainability is a real and measurable cost. Building on agent-written code, at least for now, can be riskier and lead to more failures down the line. It's a call for us to develop new benchmarks and new ways of thinking that value not just getting a task done, but getting it done in a clean, robust, and maintainable way.
It's a reminder that in software, as in home building, the quality of the foundation is everything.